Hello and welcome to the presentation on Chapter 4 of the International Levee Handbook. I'm Rachel Oriana from the United States Army Corps of Engineers, and I was the lead author for this chapter of the handbook. In this short presentation, I will try to give you just a flavor of the content of the chapter by way of an introduction to some of its aspects. Chapter 4 discusses the operations and maintenance of levees. It examines the challenges a maintainer may face and suggests preventative measures and repair techniques. Key inputs from other chapters include Chapter 3, which discusses forms, functions, and failure mechanisms of levees, Chapter 5, which discusses visual inspection methods to identify and assess levee issues, Chapter 9, which discusses insights into maintaining the levee's intended design. And some key outputs to other chapters from this chapter are the routine operations and maintenance section, which is picked up again in chapters 5 and 9, and the maintenance procedures, which are discussed again in chapters 5, 6, and 9. It's recommended that the reader look at chapters 2 and 3 throughout the levee life cycle for a reminder of important issues. The first subsection in chapter 4 has 6 key parts. Those are levee maintenance management life cycle, organization of operations and maintenance, the importance of an O&M manual, activities and practices of asset management, general approaches to O&M, and the scope of O&M and Chapter 4. The first portion of 4.1, the levee management life cycle, explains how operations and maintenance falls into the entire life cycle of the levee and how it's critical for understanding the possibilities and limitations of levee operations and maintenance. The second portion takes a look at the way different organizations around the world structure the way that they approach operations and maintenance. It was identified that there are 3 key roles required to complete levee operations and maintenance. That is the planning role, including performance assessment, operations and maintenance, including the actual repair of the work on the ground, and the inspection piece. How these roles are organized varies depending on the size and nature of the managing organization. The chapter highlights key considerations no matter what method of organization is used and provides some examples of the structures used in different countries. The third subsection discusses the importance of an operations and maintenance manual. The operations and maintenance manual describes the specific tasks a maintainer should perform to ensure the reliability and durability of a levee system, as well as the methods and resources that should be used to perform them successfully. Some key elements of this subsection include the benefits of an O&M manual, some suggested comments, the types of tasks an O&M manual should define, what types of information should be included about each task, what type of emergency information should be included, and good practices related to compiling and updating the O&M manual. Section 4.1 also discusses activities and practices of asset management, and asset management for these purposes is defined as the systematic and coordinated activities, practices through which an organization optimally manages its asset performance and condition, risks and expenditures over the life cycle of the asset for the purposes of achieving its organizational strategic plan. O&M is a critical part of asset management. Also discussed are some general approaches to O&M. The section explains the benefits of operating and maintaining using a risk-based approach that takes flood risks associated with levee system into account when prioritizing operations and maintenance, as well as a sustainable approach, which includes maintaining the entire levee cross-section, effectively managing encroachments, understanding the impacts of channel and foreshore morphology on the levee, and operating for the long term. One of the items we tried to do in Chapter 4 was to create tables to guide the reader to different parts of the book. So there's an extensive table in 4.1 helping the reader to locate critical sections in other portions and other chapters of the book that might be of interest to the reader that's interested in operations and maintenance. As the title of the chapter describes, this chapter looks at operations and maintenance, and there's a section dedicated to operations. The purpose of levee operation is to assure that the levee performs its flood mitigation role safely and according to its design. This section discusses the operation of the earthen embankment and only those auxiliary structures that directly affect its operation, such as closure structures. Levee systems are operated to fulfill three critical functions. To keep water out of a levied area, for example, closure structures. To get water out of a levied area should it be inundated, for example, needing to pump the water out if it enters the area. And to keep the levee resilient during flood and storm events. So, for example, conducting flood fighting to try to improve levee resiliency. So the operations subsection discusses some tips on how to do these things effectively. Here are just a few examples of the types of operational activities that may be required to keep water out of a levied area. Stop logs, operational activities may include transporting material to the closure, stacking logs on top of each other to close the physical opening of the levee, covering the structure with plastic sheeting, and patrolling the structure if logs are made of valuable materials that might be stolen. It was quite an interesting example that we heard as we were putting this material together in the UK, where the material that the stop logs were made out of was highly valuable, and so people were taking it away on a barge just as the operator and maintainer was putting it in. So that is something that you need to be mindful of if that's a concern in your area. Flap gates do not require any external operation. Slide gate operational activities may include adjusting the gates, either manually or automatically up and down along the track, as well as regularly removing any debris that accumulates in the intake structure. Photos and descriptions of the types of actions the reader would be interested in, and tables showing the information in a summarized way are found throughout Chapter 4. This is just one example. The majority of the chapter discusses the maintenance of a levee. Maintenance is critical to the long-term performance of the levee. However, even a perfectly operated and maintained levee may not provide the intended flood risk mitigation if there are flaws in its design or construction. In the maintenance section, it is discussed some common design deficiencies and how to identify them, and ways to deal with these deficiencies if they are identified. Some of the consequences associated with postponing maintenance are described, as well as a summary table of common issues with earthen levees and ties to these issues and which failure mechanisms that they can contribute to. The rest of the chapter discusses specific maintenance challenges in greater detail. All of the maintenance subsections are broken down in a similar manner. They all discuss what maintenance issues you're likely to see, what they look like, why those issues, if you see them, are problematic, how you can prevent these issues from happening, how you can repair these issues if they happen, and how you can know when what you're looking at is just beyond what you're going to be able to do with operations and maintenance. While most subsections in the ILH on maintenance of levees are set up with the same subsection structure, a variety of techniques were used to illustrate key points on these topics. The following slides serve to illustrate some of the key techniques used to highlight and clearly explain the concepts. Techniques include text boxes, bulleted lists, tables, photos, figures and diagrams, as well as caution boxes. On the following slides are some examples of the topics that are covered, illustrating a variety of the techniques that were used. The topics that are covered include encroachments, vegetation management, burrowing animals, erosion, depressions, settlement, seepage, instability, cracking, slope and bank protection, closure structures, pipes, transitions, and flood walls. This is just a sampling of the material that is discussed in Chapter 4. This presentation will give you an idea of the type of information that's contained in Chapter 4, but is not meant to be a substitute for reading the complete chapter and understanding the material. Significant effort was invested by 50 levee experts worldwide to compile good practices in one place for your reference. Careful attention was paid to thinking about how different readers will use this material, and the presentation of the information was revised multiple times since the end of 2010 to create a chapter that is accessible and clear for the general reader, as well as the more experienced reader. I'm very excited to share with you the following examples of the techniques that have been used in the hopes that you will look to the International Levee Handbook as your preferred resource for well-organized material on levee maintenance good practice. One of the maintenance issues that was discussed is encroachments. Handling encroachments and encroachment permitting can be a big challenge for levee owners, operators, managers, and maintainers. An encroachment is any structure not considered part of the levee's design that when placed on, over, under, through, or near a levee might have a negative impact on its structural integrity, the levee's ability to mitigate flood risks, or on the access roads that allow the operators and maintainers to get to the levee. This includes structures directly beside the levee on both the land and water side, as well as any structures that may increase the hydraulic load. Examples of encroachments include utility lines, pipes, boat docks, stairs, homes, swimming pools, power poles, roads, irrigation ditches, and railways. Encroachments also include activities performed on or near a levee that are not related to its design or function, such as farming and excavating. This section describes why encroachments occur on a levee, why encroachments need to be controlled, 7 elements of an effective encroachment control program, for example, concise guidance, effective enforcement, clear understanding of the jurisdiction of the entity in charge of managing any encroachments that get on the levee, and good recording record keeping so that the operator and maintainer can know which are authorized encroachments and which are unauthorized encroachments. Repairs of encroachment issues, as well as discussing when repairs are beyond operations and maintenance. One element of a successful levee encroachment management program is a clear definition of the roles and responsibilities of the levee operator, any related regulating agencies, and the owner of the encroachment. Should any encroachment-related issues arise, it's very important to understand these different roles. This section describes the 7 key elements of a successful levee encroachment program, one of which is a clear definition of these roles and responsibilities. What you're looking at right here is a photo of, in the Netherlands, a home that is near the levee. Well, in this case, near means built into the levee prism. In this example, reinforcement was needed in order to ensure that this home could stay there. And in the diagrams below, you can see 2 different scenarios and how the encroachment can be accommodated by adding some reinforcements. In option 1, there's a berm with a pipe outside of the zone of influence of the levee. The zone of influence is a terminology that's used in the Netherlands to indicate where the extent of the important portions of the levee are located, so as to ensure that any encroachments do not interfere with the functioning of the levee. In option 2, the berm has a pipe inside the zone of influence, but sheet piling was added to the levee to reinforce the levee. One of the most controversial sections was the levee management section, and there was multiple experts and actually an entire sub-team that was created to tackle this subsection. Vegetation management is a systematic and continual control of vegetation on and near levees. The primary purpose of vegetation management on a levee is to preserve the levee integrity, as well as levee performance, visibility, and access in the interest of public safety. Vegetation, both cultivated and naturally occurring, has been present along the banks of rivers and other waterways long before the levee systems were constructed. Woody vegetation, which consists of plants having hard lignified tissues, or woody parts, especially stems, is very common, and it's inevitable, and it can be persistent. So that vegetation must be managed if levee integrity and reliability are to be maintained. Vegetation management on and near the levee is focused on 3 levee performance objectives: protecting the levee from external erosion, maintaining adequate access and visibility, preventing the development of vegetation-induced damages or defects. So these are the 3 levee performance objectives for which levee vegetation must be maintained. These performance objectives and how to ensure that vegetation on the levee is meeting these objectives are the focus of this subsection. The handbook recommends that vegetation management practices should also seek to balance and address sustainability issues. They can do this by minimizing adverse environmental impacts and considering objectives for habitat, aesthetics, and community values. The presence of woody vegetation introduces uncertainty in the reliability of levee performance. The associated scientific issues have not been fully resolved. And as a result, different countries have adopted or intend to adopt a range of practices for the management of woody vegetation on their levees. Many of these practices are common to all countries, but there are interesting differences in the primary concerns that were considered when developing the different management practices. Access and visibility is extremely important to the United States. Seepage and internal erosion along decaying root lines were a key critical factor that was considered when developing some guidance in France. And tree blowover was examined and accommodated into some of the guidance in both the Netherlands and France. There are two primary situations that all of the policies worldwide address. Situations where levees have been kept free of woody vegetation, and situations where woody vegetation is already present on the levee. In the first situation, nearly all of the guidelines and standards worldwide recommend only a trimmed grass and turf cover, unless specifically designed planting berms or other measures are incorporated into the levee design. These guidelines and standards include procedures for the care and trimming of grass covers, and generally recommend that such levees remain free of woody vegetation. The second situation is more challenging to manage, especially where the vegetation has been allowed to establish and mature, and where vegetation is considered to be of benefit to the environment, community values, or community aesthetics. There are additional concerns associated with financial constraints and how to properly remove woody vegetation without harm to the levee integrity. Many countries have allowed woody vegetation to exist on levees for decades, and they're just now addressing these situations. Some agencies allow woody vegetation to remain if it is trimmed and thinned, or where oversized levee sections and berms can allow for such vegetation to remain without significantly affecting the levee integrity. As I mentioned previously, the vegetation subsection was one of the most controversial subsections in the entire International Levee Handbook. One of the techniques that was used by the authors of the subsection to come to agreement on what to include in the subsection was to agree on the fundamental underlying concerns and work from there. Listed here are the deterioration processes the authors agreed were the potential deterioration mechanisms associated with woody vegetation. Just a few of those listed here include blowover and overturning, root penetration, woody vegetation weight and wind loading, scour flows, burrowing, discouraging adequate growth of grass and turf, and damages to the revetment. So as you can see, this table discusses what those different deterioration processes are, and notice that the title of the table is a summary of potential deterioration mechanisms. So this is including all of the deterioration mechanisms that have scientific evidence to back them up, as well as others that are a common conception of those, and there's no scientific evidence to discourage that. One of the other items that was discussed in Chapter 4 is the burrowing animals. I included a photo on this slide to show you one of the innovative techniques that I was informed of during the creation of this chapter, which is the use in France of a metal mesh that's placed on the slopes to prevent burrowing animals from burrowing into the prism. In this image, you can see an example of erosion and bank caving. This specific example is on Park Creek, where deposits have concentrated the river flow close to the levee. Because the flow is more intense on the outside of the curve, the portion of the levee that was in the area was heavily eroded during the 2006 flood, as you can see in the figure. Once the grass cover was removed from the levee and the unprotected earthen material was exposed, erosion progressed very quickly. This site was repaired by armoring the toe of the levee, and no damage was done to this levee section during the largest flood event in record, which occurred in September of 2011. This slide shows the use of a table mixed with diagrams to illustrate some key points. The example shown is one of the common causes of subsidence, and a few good preventative measures that could be taken to avoid this issue are listed. Another key issue that levee operators and maintainers may see is levee slope instability. It's important for a levee maintainer to be able to identify the signs of levee slope instability. The three main signs are described in the chapter with illustrations. The signs are discussed as slumps, slides, and tension cracks, and as well as a description and diagrams for learning how to identify these are discussed in the chapter. Here's an example of a diagram showing how you can recognize slope instability. Cracking was another issue that was discussed in Chapter 4. Understanding the difference between desiccation cracks and structural cracks is important because desiccation cracks are typically of low concern, while structural cracks are typically of high concern. This table can help you to understand the difference and to know what type of crack you're looking at and why they might be of concern. One of the highlights of the subsection on levee slope and bank protection is a table with photos illustrating the different types of levee slope and bank protection with a brief description and details on the maintenance needs of what type of bank protection is being described. So here's an excerpt from that table. You can see an excerpt, a photo of riprap, what it is and where it could be used, as well as the types of maintenance needs that riprap might have. Closure structures are also discussed in Chapter 4. Closure structures are removable, watertight mechanisms used during flood events to seal off levee segments whose heights have been reduced below design grade by an intersection. Sometimes that occurs because of a roadway, a railway, or another crossing. Note that for the purposes of this handbook, closure structures are on the order of tens of meters long, rather than hundreds or thousands of meters. Two abutments, a cast-in-place concrete wall perpendicular to the levee or flood wall at each end of the opening, and a sill, the base of the opening that carries the closure structure's weight, typically frame the closure structure's opening. Cut-off sheeting is often driven below the opening to prevent the undermining or seepage, and sandbags and flexible seals may be used to prevent leaking. The structures are normally left in the open position and are closed or installed in advance of a flood event to provide a watertight seal. Note that closure structures do not include demountable defenses located on top of a levee, which raise the levee defense at the time of flooding. However, the principles of maintenance of demountable structures are very similar to those of closure structures. There was a great effort by the Chapter 4 team to try to include photos as well as diagrams and text boxes to illustrate all of the different points. The slide you're looking at illustrates one of my favorite stories in Chapter 4. This text box describes an annual competitive training exercise that's sponsored by the Sunbury Municipal Authority in Pennsylvania in the United States. And this exercise is done to improve the efficiency of people responsible for closing structures. Each year in the autumn, the authority coordinates a simultaneous closure structure training exercise at various locations throughout the city. This exercise is scheduled as a competitive event where authority crews and volunteer crews from several fire departments compete against each other to try to beat previous installation times. The event rotates authority and volunteer crews in an effort to reduce response time during an actual flood event. Following each exercise, crews meet to discuss ways to improve on their times for the next training event. And to date, records indicate that each year the rotating crews have been successful in beating the previous year's installation record. And in many cases, installation times have been reduced to just minutes. Another subsection that was of great interest to the Chapter 14 was culverts and discharge pipes. Culverts and discharge pipes are systems that are built under, over, or through a levee to provide drainage as a part of the flood risk mitigation system, typically from the land side to the water side. And these culverts and discharge pipes must retain the flood water. When the culverts and discharge pipes that must retain flood water are discussed in Part 1, and those discharge pipes that are a part of utility pipes and line systems are discussed in Part 2. So in Part 1, it's discussed why culverts and discharge pipes are of concern and some different tips for maintenance. Those maintenance tips are divided into 3 parts. Maintenance that's geared at avoiding internal erosion, maintenance that's geared at avoiding external erosion, and maintenance that's geared towards avoiding levee slope instability. So as you can see, culverts and discharge pipes have the potential to significantly contribute to levee deterioration processes greatly. Repairing culverts and discharge pipes is also discussed in Part 1, as well as the maintenance of culverts and discharge pipe system components. Culverts and discharge pipe systems are of great concern when they're not properly maintained. Lack of proper maintenance increases the risk that the levee system will fail as a result of internal erosion, external erosion, or levee instability. And these 3 failure mechanisms are discussed in more detail in Section 3.5. So Part 2 suggests some preventative measures and repair techniques that can be used when maintenance issues are observed. These measures and techniques are grouped according to the failure mechanism they are intended to prevent, which are the maintenance of pipe issues that can cause internal erosion, external erosion, and levee instability. Also included is a separate section on the maintenance of culverts and discharge pipe system components, which include flap gates, sluice gates, slide gates, air relief valves, and trash racks. At the heart of proper pipe maintenance is a program of regular levee inspections. These inspections identify and report maintenance issues before they result in such serious concerns as pipe deformation, leakage, or internal obstructions. For details on conducting and documenting inspections, see Section 5.3.4. One of the techniques that was used in Chapter 4 is the text boxes. Text boxes illustrate some of the key points. What you're seeing on the screen here is one of my favorite illustrations of the criticality of proper operations and maintenance. What you're looking at is where on the Jefferson-Clarksville levee in Indiana, 2 1.8 meter diameter corrugated metal pipes collapsed in 1996. This collapse occurred beneath the 10.7 meter tall levee embankment. This section is within the jurisdiction of the ESACE Louisville district. These pipes were 50 years old. Luckily, the pipes did not fail during a flood event. But had they failed during a flood event, the resulting sinkhole might have caused the levee fail to have internal erosion or to have an overtopping breach. To repair the levee, the entire levee section was cut open and pipes were replaced. This experience inspired the Louisville district to create an inspection program to ensure that flood control system pipes passing through the levee are not threatening the levee integrity. Inspections are done by physically entering the pipes or by remote video inspection. Levee transitions can be one of the weakest points in a levee. Anytime that there's a change in material, you have a levee transition. Section 4.16 looks at deciding whether a transition zone is problematic, as well as preventing internal and external erosion at transitions by maintenance, and how you can repair erosion if you see them at these transition zones, and how you can determine when the repairs are beyond maintenance. Here's a few photos of the different types of transitions that you might see. Flood walls were also discussed in Chapter 4. Flood walls are flood risk mitigation structures of either gravity or cantilever design. In the context of levees, they are used when space does not allow increasing the levee cross-section. Maybe the right-of-way is not available, or the levee foundation cannot support the weight of additional earth fill. A well-designed and constructed flood wall can provide long-term service while requiring minimal maintenance and fiscal resources. Clear zones should be established and maintained along both sides of a flood wall for inspection, maintenance, and flood fight purposes. A minimum zone of 4.6 meters measured from the face of both sides of the wall provides adequate width. The zone should be kept free of all vegetation other than maintained turf. Planting in the zone should be prohibited. Root systems can induce external forces that may lead to wall instability or localized deterioration. Also, this clear zone should not be excavated or used for storage of other structures. Walls can be particularly susceptible to severe fire events, so flammable material should never be stored adjacent to the flood walls. Some key items discussed in this section are how you can prevent flood wall deterioration, repairing common flood wall problems, and determining when repairs are beyond maintenance. One of the highlights of this subsection is a table that identifies observations, potential impacts, and preventative measures associated with issues on the flood wall. One example is shown here. So in the observation detailed in this example, erosion of cement paste on a flood wall surface is exposing more durable aggregates beneath and resulting in a roughened or textured surface. So the potential impact that can have on the levee is that there isn't a specific immediate impact, but it can induce scaling, spalling, and microcracking. Spalling is the deterioration of concrete by flaking and crumbling. So it's good to be aware of the possible preventative measures that can be taken, including considering applying protective coatings by spraying or painting to retard this process. Summary tables, such as this one, were used in areas throughout Chapter 4, and the Chapter 4 team invested significant energy and time so the format would be as user-friendly as possible. The Chapter 4 team sincerely hopes that you enjoy the Operations and Maintenance chapter of the International Levee Handbook. Thank you for listening to this presentation. I hope that it has given you a flavor of the coverage of Chapter 4 and encourages you to investigate the other chapters of the International Levee Handbook, which have similar presentations. The complete handbook can be downloaded from the CIRIA website, the link to which is given on the current slide.